Welcome back to Journey into DevOps. In this Linux video, we're going to be looking at a number of very important concepts that will make you really solid when it comes to the Linux operating system. And that's file descriptors and redirections and talking about open files. And we'll just try to understand what exactly these things mean, what they're all about, how to see them, how to access them, have a bit of demo on them. And without further ado, let's get into it. First off, we need to understand that when a process starts, it uses many libraries. And if you don't understand what a process means, let me quickly explain it to you. Remember we said that every command that you run on Linux is a program. So we've been using ls. ls is a program. If we use vi to open a file, it is a program. If we did a cat on the file, that's a program. And each of these programs, they internally use libraries to function. Now these libraries could be modules from the kernel. It could be certain other libraries from the program itself. For example, if it was a Python program, with Python we do have import statements that import other libraries, which is essentially a collection of different functions and commands and all that. Now every time we run these commands, each of those libraries, which are represented by files on the file system, get opened. And it is very important for the kernel to keep track of every open file. And that's where the whole concept about file descriptors came about. And by the way, remember, everything on Linux is about files and directories. And if it's about files and directories and the Linux kernel is not able to keep track of every files that is being opened on the system, then what sense is in there? So it only makes sense that there is some way in which every file is being tracked. And that's why in Linux there are many different types of tables. In the previous video we looked at the inode table and the file table. And right now we're going to look at a special type of table called the file descriptor. Now take note, even though I've called the table file descriptor, it is actually the entries in these tables that are file descriptors. And only the Linux kernel is able to update this table because that entry only happens when there is an open file. But why do we even need file descriptors? Well, like I said before, it's basically to track every open file on the system. But then again, it's a way for the kernel to help the program that is requesting for this file to give it more information about how to access the file, where on the file system these files are. And so the file descriptor itself points to the file table, and remember, the file table points to the inode table. So each time there's a file opening, there's an entry in there that points to the file table specific to that file, and in the file table is the inode entry. That of course gives it more information, metadata about the file. Now in this video I'm gonna spend a bit of time to focus only on the first three entries in the file descriptor table, because these three entries play a very major role when you're writing shell scripts or doing a number of things on the Linux terminal itself. And we'll be doing a bit of demo on that. But before then, I want to also talk about redirection, because it is not every time that you run a program that you want it to print on the screen. Sometimes you want to redirect the output into some file, and that's when we do something like echo hello and use the greater than symbol to send that data hello into some file. So if we do a cat on some file, you can see hello. So this greater than here is the redirection I'm talking about. So we have redirected. And by the way, still on redirection, what if we want to append to that file? If we said echo my name is Dare into some file, let's see what happens. It actually replaced what was in there with the new data. But what we want to do is not that. What we actually want to do is to append the data to it. So rather than using the greater than symbol alone, I would use the double greater than symbol. And this time around, I can say I am learning DevOps. And if we do a cat on that, as you can see, now we have an appended data. So what I like to do in this video is to bring together the whole concept around file descriptors and redirections and open files, so that you have a complete understanding of what's going on, both within the kernel and the Linux file system, and how to operate when open file issues arise on the system. Okay, the first three file descriptors by default are the standard in, standard out, and standard error, and these are represented by numbers. So if you look at the table for file descriptors, you would see the 0, the 1, and 2. The number 0 represents standard input, and standard input represents the data that you input into the system from your keyboard. And this data, by the way, sometimes you would see it referred to as data stream. So it's the data stream that goes from your keyboard into the system. The number 1, on the other hand, which is the standard output, is a data stream that prints onto the screen. So standard in takes the data in, standard out prints the data on the screen. So what we have on the screen here when we do a cat on some file is a standard output. Now number 2, on the other hand, is the standard error, because there are basically 3 things that happens most of the time. You type in your keyboard into the system, you get some data back, and part of that data sometimes can be an error. And that's why we have the file descriptor number 2, which is the standard error. And all of these have their abbreviations. So standard in is std in, standard output is std out, and standard error is std error. Now if you're wondering, how exactly does all this fit together? Well, let's have a bit of a demo. And I'm going to use that opportunity to introduce you to another new command, which is the find command. So we're going to find a file on the root directory, and we're going to try to do this without the sudo command, which is the elevated permission command that allows us to run things with the elevated permission. And that should give us some errors, because without permissions we won't be able to access the file. So ls on the current directory we have diary.io. Let's look for diary.io, and I'm going to say find the entire root file system. And what am I looking for? I'm looking for the name of a file. Oops, I don't know what I did to my keyboard there, but I'm looking for the name of a file, which is called diary.io. So everything you've seen is from standard in with the file descriptor 0. Now if I hit enter, what you're seeing on the screen is standard output with a file descriptor number 1. So there's a file opened by the kernel with a file descriptor number 1 for bringing back this on the screen. So don't forget, we're talking about file descriptors and open files, and we're going to go deeper into open files shortly. But bear in mind that std output of file descriptor number 1 is printing this out to us. But if you take note, even though, let's see if it actually gets the data for us. Here it is. This is the data we're actually looking for. We know it's in home diary, desktop, diary.io, which is the file, but we do have other errors. So all of these permission denied are all errors. So that means even std error has been used as part of this operation. So let's see if we can actually redirect the entire output into some file. We should be able to do that, shouldn't we? We know the greater than symbol can do that for us. So let me use the shortcut, which is !mark and F. So let's find the last command with the Ctrl R, and this time around I'm going to send the data into std out. Why not? .txt, so we know it's a file. What you would notice is, even though I've sent it to a file, we're still seeing the whole thing on the screen. We shouldn't be seeing everything on the screen. Let's see if it actually stored anything in that file. Sure enough, we have something, and just one thing, see, which is exactly what we're looking for. The command that we asked it to do, which is to find the file, that's the only thing that's written in this file. And why did that happen? Well, that's because by default, remember I said the default file descriptors, which is 0, 1 and 2, by default the standard output for this command find, is sending it out into this file. We haven't told it to send the default file descriptor for errors. So the only thing we're seeing on the screen is the error. So rather than printing the data we're interested in on the screen, we've actually sent that to a file. How about if we want to send this whole error message into a file and show us the return data on the screen instead, because that's what we're actually looking for to do? Well, what I would do would be to say, remember the file descriptor for error is number 2, so I will put that number 2 over there and say error.txt, and sure enough we have the actual std out which we're looking for on the screen. And if we do a less on the error, we have all the errors written to a file. And what we've just done is essentially what we call the redirection. And by the way, you would see things like this more often. Rather than sending an error data into a file, in script you would find things like dev null, which is essentially writing the error messages to some device that is null. Null means nothing, so right, so it's sending the std out on the screen for us, but then this is just going away. We're not interested in the error, and that's literally a cleaner way to do things. Now let's talk about the other file descriptors that are not the default one. Remember I said that the file descriptor table keeps a record of every open file. So if we started a process and that process opens up a file or many files, it stores extra file descriptor entry into the file descriptor table, and these entries are in the form of integers that are non-negative. So you can have from 522, 533, 547 up to several thousands of numbers, because of course there are potential for opening thousands of files on the system, especially because Linux is a multi-user based system. There can be many users signed in at the same time, all running different programs that are also opening many files. With a quick demo, let's actually start a program and see the process with the files it's opening up. And the program I like to start is the Vim program. We'll be using Vim to open up files and make edit, and I'll use Vim to open the error file we just created just now, and I would like to send that to the background. And we're going to be talking about background and foreground in later videos, but for now just use the ampersand symbol to send a process to the background. And what you would see is a process ID, and don't forget, a process is an instance of a program. So if another user runs this program again, it would have an instance which then creates a process ID. And if we use the ps command, and ps means process status, and use the ef flag and pass that into a grep to only filter out the process ID above. There are two things I'd like you to take note of with this command, which are still related to redirections. Now, the ps command, if I run it without the pipe, is making use of the std1 file descriptor to print out everything on the screen. And using the pipe tells you that the pipe takes in std1 by default. And so passing all the standard output into grep, which is a program we can use to filter out what we're actually interested in. And in our case, we're interested in the 5564 process, and that's only going to give us the Vim program that is opening the error.txt command. So that's another file descriptor I'll play here. Now what I'd like to demonstrate is to see all the open files that this program is making use of. And there's a program that can help us to do that. It's called lsof. You may not have that installed by default. If you do, that's fine. If you don't, just use the apt command to install it. And if I run lsof on this process, we need to use the pipe and grep to grep for 5564. What you're going to notice is this same process has opened many files. Remember when we were talking about the directory tree structure, we said that in the usr lib folder we have libraries. Now Vim is using many libraries to do its job. So one of the libraries here is the lib verb.bis file. I don't know what that is, but from the extension you can see it's a kernel module, and there are so many others. Now each of these are open files because this library is open, this is open, this is open, they're all open, and just one process is making use of all these open files. Each of these open files have entries in the file descriptor table. And how will this Vim process know where on the file system to locate this file? Well, the file descriptor table has a pointer to the file table, which then has a pointer to the inode table. And that's how this program is going to know where on the file system to locate it, to say it's in this directory. And to give some final notes on open files, it is very important to understand the concept and making use of the lsof command, because as a DevOps engineer or a systems administrator, there are times where the system can start having degraded performance issues, or a program can start having errors which are related to open files. And with the lsof command, you're going to be able to figure out if there are too many open files on the system. And by the way, it is a configurable thing in Linux to set the maximum number of files to open and things like that. So there are so many things around that, which is absolutely beyond the scope of this video, but this is meant to serve as a fundamental step to understanding how these things work. So I hope this video has been very informative for you, and I hope to see you in the next video. Don't forget to subscribe.